Space often appears serene, a silent, endless ocean scattered with gentle pinpricks of light. Yet beneath that calm lies unimaginable violence. Every star, every flicker we see across the night sky, is part of an eternal cycle of creation and destruction. When stars reach the end of their lives, they don't fade quietly. They explode in events so powerful that for a brief moment, they can outshine entire galaxies. These are supernovae, nature's most spectacular and devastating fireworks. Imagine a dozen or more of these explosions happening close to one another, cosmic detonations so fierce they carve immense hollows through the galaxy. The shockwaves sweep away clouds of gas and dust, clearing vast voids while heating the surrounding material to millions of degrees. These hollowed-out regions, known as superbubbles, are the graves of dead stars, and the cradles for new ones. Our own solar system, surprisingly, drifts right through one of these ancient scars. Long before humanity, even before Earth had its modern continents, a series of colossal stars reached their ends and reshaped the very space our planet now travels through. This region is called the local hot bubble, a gigantic cavity of thin, superheated gas stretching hundreds of light-years across. We don't just live near it, we live inside it. Scientists first suspected its existence in the 1970s when mysterious, low-energy X-rays seemed to fill the sky. Decades later, data from NASA's missions confirmed that these signals weren't from our solar system at all but from this bubble of hot plasma surrounding us. It's a cosmic echo of destruction, the residue of about 15 supernovae that once went off in close succession, sweeping out the dust between stars and leaving a turbulent, glowing scar in space. What's fascinating is that these violent deaths gave birth to life elsewhere. The same shockwaves that tore through space also compressed nearby clouds of gas, triggering the formation of new generations of stars. Even our night sky's glittering young clusters owe their origins to those ancient explosions. We often think of space as static, but our solar system is literally sailing through the debris of long-dead suns. It's a reminder that creation often begins with catastrophe, and that even in destruction the universe finds balance. But how exactly did scientists uncover the story of this invisible bubble surrounding us? And what clues hidden beneath Earth's oceans might reveal the timeline of those long-lost cosmic blasts? If you could see our corner of the galaxy through X-ray vision, you'd notice something extraordinary, a glowing, irregular shell of superheated gas surrounding us on all sides. This is the local hot bubble, a relic of cataclysms that took place millions of years before the first humans walked the Earth. The story of how scientists pieced together its existence is one of cosmic detective work spanning decades. Back in the 1970s, astronomers using early X-ray detectors found a strange glow coming from every direction in the sky. At first, it didn't make sense. Where could such widespread radiation come from? Some thought it might be leftover noise from the instruments themselves. Others speculated it came from the interaction between the solar wind and neutral atoms within our solar system. Yet the evidence didn't quite fit. The glow was too uniform, too powerful, and seemed to originate far beyond the heliosphere's reach. It wasn't until 2014 that NASA's Diffuse X-ray emission from the local galaxy, DXL, mission delivered proof. The mission revealed that only about 40% of those X-rays came from within our solar system. The rest were streaming from a vast, million-degree bubble of plasma, the remains of multiple supernova explosions that had scoured a cavity in the interstellar medium. Geological records on Earth later added another clue. Deep-sea sediments contain traces of iron-60, a rare radioactive isotope created in supernovae. Because this isotope decays predictably over time, scientists could date when the material arrived on Earth, roughly between 6.5 and 1.7 million years ago, aligning perfectly with the suspected timing of the explosions. Similar samples from the Moon confirmed the extraterrestrial origin of the isotope, leaving little doubt that our solar system had been showered with debris from dying stars. Researchers now believe around 15 supernovae erupted in relatively quick succession, each one adding to the growing cavity and pushing out interstellar gas. The chain reaction left a gigantic void, the one our Sun now drifts through. Using data from the European Space Agency's Gaia telescope, astrophysicist Catherine Zucker and her team reconstructed the bubble's expansion in 3D, showing that young stars today form along its edges, where the compressed gas continues to ignite new stellar nurseries. Our galaxy, it turns out, is full of these cosmic bubbles, like holes in Swiss cheese, each carved by explosions and connected through tunnels of hot gas. The space between the stars isn't empty, it's alive with the memory of destruction and rebirth. But what happens when such a stellar death doesn't stay distant? When one of these cosmic bombs goes off close enough to endanger life itself? Let's explore that chilling possibility when stars die too close. Imagine stepping outside one night to see a new light in the sky, so bright it rivals the full moon, casting shadows even at midnight. For a few seconds, it's dazzlingly beautiful. But beauty in the cosmos often hides danger. That blazing point could be the last scream of a dying star, a supernova, and if it's close enough, its fury could reach Earth in catastrophic ways. Supernovae are among the most violent events in the universe. When a massive star collapses or a dense white dwarf tips past its stability limit, the result is an explosion so energetic it can outshine entire galaxies for weeks. These blasts release floods of gamma rays, X-rays, and high-speed matter traveling at thousands of kilometers per second. The shockwaves sweep across space, reshaping everything in their path. Fortunately, supernovae within our own galaxy are rare. Astronomers estimate only 2 or 3 occur per century in the Milky Way. But rare doesn't mean impossible. Evidence suggests that Earth has been brushed by their effects before. Layers of iron-60 found in ancient sea sediments tell us that one or more nearby supernovae detonated within a few hundred light-years of us around 2 million years ago. They were far enough away not to sterilize the planet but close enough to dust it with radioactive debris. Scientists have long wondered what would happen if a star exploded closer, say within 25 light-years. The first blow would come as a burst of gamma radiation, capable of stripping Earth's ozone layer and exposing life to deadly ultraviolet light. Next would arrive a stream of high-energy particles, potentially disrupting satellites, magnetic fields, and even the chemistry of our atmosphere. For a truly near supernova, a wave of stellar debris could reach our solar system thousands of years later, stirring up chaos in the outer planets. The good news? There are no immediate threats. Even the most famous candidates, Betelgeuse and Antares, both red supergiants nearing the ends of their lives, lie more than 400 light-years away. If either were to explode, it would dazzle our night sky for months but pose no danger. In fact, witnessing such an event would be one of the most breathtaking sights in human history. So while we live surrounded by ancient evidence of stellar death, our present moment is blessedly calm. Still, every glowing remnant and every flicker of radiation reminds us how fragile our cosmic neighborhood truly is. Yet, as our telescopes grow more powerful, we're learning that the universe hides far more than explosions. Entire regions of the Milky Way concealed behind veils of dust, waiting to be revealed. Next, peering through the dust, Vista's hidden map, we uncover the secrets long lost in the dark. For centuries, astronomers have stared toward the heart of the Milky Way, only to be met by darkness. Thick clouds of cosmic dust and gas cloak the galaxy's most mysterious regions, hiding billions of stars from view. But what if we could lift that veil, to finally see what lies beyond? Thanks to modern infrared technology, that mystery has begun to unravel, and what we've found is nothing short of astonishing. The breakthrough came from the VISTA telescope, the Visible and Infrared Survey Telescope for Astronomy, located high in the Chilean Andes. Over 13 years of patient observation, VISTA has built the most detailed infrared map of the Milky Way ever made. Unlike traditional telescopes that rely on visible light, VISTA peers through longer infrared wavelengths that can slip through the interstellar dust. What once appeared as empty blackness now glows with the light of over 1.5 billion celestial objects, stars, newborn clusters, and ancient remnants previously hidden from human sight. This colossal survey, known as the VISTA Variables in the Via Lactea (VVV) project, has transformed our understanding of our galaxy's structure. By capturing nearly 200,000 infrared images, scientists have stitched together a 3D map showing the true texture of our Milky Way, its bulging center, spiraling arms, and the intricate web of star-forming regions weaving between them. Among VISTA's most exciting discoveries are the Cepheid variable stars, those rhythmic, pulsing beacons that expand and contract like cosmic heartbeats. Because their brightness follows a predictable pattern, astronomers can use them as standard candles to measure distance. Dozens of these Cepheids have now been identified in areas once thought barren, revealing a thin, hidden disk of young stars running straight through the galactic core, a region once believed to hold only ancient stellar populations. VISTA's map has also uncovered globular clusters, spherical gatherings of tens of thousands of ancient stars, lurking behind the dense curtains of dust. Each one serves as a fossilized remnant of the galaxy's youth, helping astronomers trace how the Milky Way grew over billions of years. One particularly thrilling find was a pair of clusters that may be gravitationally bound, a possible binary globular system, the first of its kind ever identified in our galaxy. The infrared universe is reshaping what we thought we knew. It reminds us that darkness often hides brilliance, and that even in the densest fog, light finds a way through. But all these cosmic revelations lead to one humbling question. How small are we in this vast galactic landscape? To grasp our place in the universe, let's shrink everything to scale. How far away is home really? We often talk about the stars as if they're close enough to reach. The glittering dots scattered across the night sky seem almost within arm's length. But space has a way of humbling us when we try to measure it. To truly understand how vast our cosmic neighborhood is, let's shrink the solar system down to something we can visualize. Imagine the sun reduced to the size of a tiny grain of sand, just 1 millimeter across. Now the distances begin to tell a staggering story. At this scale, Mercury, the closest planet to the sun, would sit about 4 centimeters away. Venus would be 8 centimeters out, and Earth would hover roughly 10 centimeters from our tiny sand-sized sun, barely the width of a human hand. Mars drifts 16 centimeters out, while Jupiter, the gas giant, already stands more than half a meter away. Saturn lies just over a meter from the sun, and Uranus sits more than 2 meters beyond that. By the time we reach Neptune, we're already over 3 meters out, and Pluto, though now classified as a dwarf planet, orbits more than 4 meters away. If you laid all of that out on the ground, the entire solar system could fit comfortably inside a small room. But here's the twist. Our nearest neighboring star, Alpha Centauri, would be 30 kilometers away. 30 kilometers. That's roughly the distance of a marathon run, just to reach the next grain of sand. In that comparison, the immensity of space becomes almost unfathomable. The darkness between stars isn't a simple void, it's an ocean so deep that light itself takes years to cross it. Even our fastest spacecraft, like Voyager 1, traveling at over 60,000 kilometers per hour, would take more than 70,000 years to reach the Alpha Centauri system. Yet this perspective isn't meant to make us feel insignificant. It's meant to remind us how miraculous it is that we can even comprehend such distances. Every measurement, every image captured by our telescopes, every trace of cosmic dust or radio wave we interpret, brings that distant frontier a little closer to human understanding. We may be small, but our curiosity stretches far beyond our size. From the remnants of ancient supernovae to the hidden architecture of the Milky Way, and the vast gulf to our nearest stellar neighbor, we are explorers of infinity. The universe is vast, ancient, and ever-changing, and though we are just travelers on a tiny planet orbiting an ordinary star, our greatest journey has only just begun.